Okay. So last time we talked mostly about till the topic of basic strings, how to uh, do some basic processing, trimming, changing the lowercase, uppercase, some basic stuff. So we will basically build on that, and then we will move to a newer topic. So for today, just like previous case, we will make another folder. Okay, so here add executable lecture 3. Here I can add source file. So this I'll add here, and then I'll add another file notes. I will copy this to here and basically reset and reload. Okay. Uh, we will continue with strings, okay, and we will talk a little bit more about some common operations on strings, okay. So we already saw some common operations. For example, we talked about trimming blank space, we already covered it. Changing case upper to lower, lower to upper, we already did this, right? There are other things that we can do. We can uh, check if a string starts with another string, or we can check if a string ends with another string, or we can find all matches for a substring, or we can do split a string across delimiter, or maybe multiple delimiters, or we can merge bunch of strings together. So these are some of the common operations that we will cover today, because these are again the operations which you will be doing many times in your life, anywhere you are dealing with bunch of strings. Okay, so we will basically cover some of them. Let me see if the CMake is finished. Okay, it is finished. Fine. And there are some other cases as well. For example, we can also do search and replace part. So basically replace substring in another string, or uh, erase substring in another string. Okay, so we can add these two cases as well. So we will start with them, and just like previous case, we have a simple string here. Okay, and for starting, we will start with basically erase and replace part. So let me put something else here where I can replace. Okay, this is a dummy string. Okay, and I want to erase the word dummy. So what I will do, I will basically do boost algorithm and erase all str1 and this one. Okay, and then I will print this string, and let us see what happens if I run it. Build finished. Wait, I need to run lecture 3. So now here we see that this says this is a string with double spaces. This part is simply removed. If I add one more space, it will basically remove this entire part. Okay. Now if I have multiple occurrences, something like this, or maybe two consecutive occurrences, and then I build and run this again. And again I get output as this is a string. All the occurrences of this is removed. Now if I don't want to modify this string in place, I can create a copy using erase all copy, and then I can uh, mm, and then I can print both original str1 and then updated now here my original string is not modified in place, and I am getting the modified copy in another string here. Okay, so this is how we can erase. Similarly, we can also do erase at a specific location. Okay, so for example, if I want to erase it some specific place, so suppose I want to 1, 2, 3. Say suppose I want to erase the second occurrence, right? So instead of that, what I can do, I can do erase nth copy str1 int nth and the string to search erase nth copy. Okay, wait, it is in opposite order. Okay, and now I can build and run it. Okay, now I am asking here to only replace the second occurrence and leave everything as it is. So we can compare this. This is the first occurrence, it is not modified. This is the second one that is removed. Third one is remaining here. Okay, similarly, if I do here as one and run it again, my first copy, but this first occurrence will be removed. Everything else will not be removed. Okay, so we can do this. Now here the first occurrence is removed. Okay, now if I want to remove the last occurrence, right, and I don't really know how many times it is going to appear. So one option will be to somehow find all occurrences and then find the last one and then do this erase nth copy, or instead of that, what we can do, erase last copy, and it will basically find the last copy and remove it. Here, this is the last occurrence in the string, so this part is removed. So this is how we can basically erase part of a string. Now, instead of eraser, if I want to replace it, replace substring with another one. Okay, and what I want to do, I want to replace this with some other string. Okay, replace dummy with magic. So what we can do same updated as boost algorithm, uh, replace all str1, search dummy, replace magic. Oh wait, replace all, copy, and then we print this here again. Now here this string has been updated, and we have basically replaced part of one string with another string. Okay, similarly, just like we were doing this erase nth position, erase last position, that can be done with replace as well, right? So if I want to replace, say, nth position, so I can do replace nth copy, magic, and 0. Wait, where's the position? Okay, it is directly replace first, last, or something. Okay, then probably we can only do replace last if we want to replace the last one. And here everything else is left intact, only the last part is replaced with this one. Okay, now we want to join bunch of strings. Okay, so I will just remove this, and now what we will do, join bunch of strings, right? In previous lectures we already covered basically vectors. So what we can do, we can create a vector of a string, and we can basically, this is some string data. Okay, so we have these individual strings, and what I want to do, I want to join these strings. Okay, so what I will do is td string combined equal to boost algorithm join data, and I can specify some separator. Okay, so if I say one space here, so what it will do, it will join all the pieces separated by a space. Oh wait, I did not print it. Okay, so now it is joined with spaces. Now if I put something else here, I can put something like this, and now it will put this entire string as a separator between all pieces and turn this whole thing into one bigger string. Okay. Uh, Similarly, now suppose we want to split some string. Okay, here we are taking the piece and joining it, and now we want to do the opposite, split the string. So what we will do, we will have some string uh, music equal to this is some sample string. Okay, and we want to split it across some delimiter, and after split it will be basically uh, a list of individual strings which we want to store in some vector. So we will declare a vector to hold the split strings, and then we can do boost split. Split, first one is result, then second one is input, and then we have to specify the delimiter. So boost is any of, and we specify this one. Okay, and then we will simply print this string. So for auto combo word dl. Okay, so this was the original string, right? And we have spread it across space, and now we are getting individual words out of this string. Now there can be cases where we have multiple delimiters, right? Here I have only one. Maybe I can have multiple delimiters. For example, which is delimited by more than one delimiter. Okay. Now, if I have this string and I basically uh, run it as is, here I see that this semicolon is part of the word, right? But this should not really be part of the word. This should act as yet another delimiter. Or maybe I can have something like this, right? So what I will do, I want two delimiters. So one is a space that will remain as this. Then the second will be this one. So I specify both here in the same string. And if I run it now, now here it is separated across this semicolon, as well as other words are separated across the white space as we expected them to be. Okay. Similarly, here we can specify 4, 5, 6, or maybe even more number of delimiters. And what will happen that the string will be broken apart across any of the delimiters which is specified in this particular string. So we don't really have to parse the same string repeatedly one after another. Okay. Any questions so far related to strings? Any questions? Could you please save the code intermittently? Do you want me to share the code? Okay, fine. I will try to save the code and not remove it. Anything else? Okay. Okay. Now we want to find some substring. Check if string contains another substring. Okay. So what we can do, say we have this sample string and we want to search for sample. Okay, so what we can do, we can do something like this. If magic dot or find magic dot find, and we can specify the substring here. Let us say we want to search for this one, and we can do something like this: substring found, and run it again. So here it says that substring is found basically. So here what I am doing, I just did that string dot find specified the substring, and I am simply comparing it that the position that it is telling me it should not be invalid. Okay, now the catch is that it will only basically tell me if it has found the string or not, and what is the first position that it has found it, right? It will not immediately tell me basically all the positions in the string where the same substring has been repeated. If you want to do that, you can check the first occurrence, then you can move forward that and find again and again and again until you basically stop finding that particular substring. So basically you have to do the same thing inside a loop, and every time you will be taking this position from here and basically cutting the string by that much, and then try to find this again on the remaining string. So I suppose, okay, uh, starts with and ends with is pending. Okay, now I want to check if string starts with. So that is again is simple boost rhythm starts with, and it is music, and this stdc out string starts with this. Okay, so we can run it. It says string basically starts with this. If I change it to something else, it prints substring found, but it does not print this one because this string does not start with foo. Okay. Similarly, we can check for end with as well. Music, and copy this. Mm. Now here it says that a string ends with delimiter because this substring that we specified is in the end of the string. So that is how we can do most of the common operations on strings, be it checking for string starting or ending with some particular substring, checking presence of some particular substring, erasing part of a string based on some substring, replacing substring with some other substring, splitting the string, merging the different strings into one larger string. So these are the common operations that we have covered so far. Now we come to the next topic, and next topic is basically functions. Now so far what we have done, we have basically crammed everything inside this main, that is basically the basic template of a C++ program. We crammed every damn thing that we wanted to do inside this main thing, right? Now we have a problem. One is obviously is that we may end up having crap ton of code inside main, and now we won't be able to make sense of it if it grows too much. The second problem is that many times we will be doing basically same thing on different data again and again and again, right? For example, if I am parsing, I am dealing with some text data, there will be cases where I am doing some sort of sanity check on that text. Okay, and that sanity check will often involve a series of checks one after another. Okay, for example, if you are parsing something, you may have checks like, okay, this should start with this, end with this, it should also have at least this number of this, something like that, right? Now, if you have such multiple conditions, one option is that you uh, copy paste the same set of code everywhere you want to do the same set of operations on the different data. Okay, but again, the problem is that if we have to make any change in that set of operations that we are using at multiple places by doing copy and paste, we will have to find all such places and fix it at every single location in our program. And if we miss any place where we copied the original code but we forgot to apply the fix, obviously bad thing will happen. Okay, we may end up getting garbage output, no output, something entirely different. We have no idea. So, to avoid that headache, what we do instead of manually copy pasting the same lines of code and replacing the variable name everywhere we want to use that, we basically try to abstract it away. So, what we do, we pull out the repeated lines of code, we place it somewhere else, we give it a name, okay, and then in rest of the program we refer to that separated block of code with the name that we have given to it, okay, and then when we compile it, compiler will basically find all these blocks by name and do its thing to ensure that the compiled binary still works as it should, okay. The good thing is that since instead of having multiple copies of same lines of code, we have only one copy. Okay, we have to apply fix or do some changes at only one place, and it will be applicable to basically anywhere else in the code where the same set of lines is referred to. Okay, so we when we basically remove these lines of code, put it somewhere else, and give it a name, we call it this thing a function. Okay, so the basic syntax is something like this. Okay, so uh, block of code which is given some friendly name. Okay, syntax is pretty simple actually. It is return type, function name, then in parentheses, uh, list of parameters if any, and list of parameter goes like this. It will have, is my screen visible? It seems screen, एक minute, visible now? Okay, so list of parameter will be like data type and parameter name, and it will be separated by a comma, and there can be 0 or more than 0 parameters. Now, when we say this return type and data type, so this return type can be any of the valid data types, okay, or it can also be void. So when we say return type, it can be any valid data type or it can be void. When we say that return type is void, This means function does not give anything in return. Okay. Now, when we say that function is giving something in return, or function is not something giving, is not giving something in return, what do we mean by this? If you look at the code here, okay, we have done things like this here. Okay, so basically, this join is a function which is taking two parameters and it is giving us the combined string back, which we are able to save in this particular variable. So here we say that this function is returning a string. Similarly, there can be cases where function does not return anything. It will do something, but it will not return anything. So in that case, we can't really store the returned value in uh, some variable. Now, for this function name and parameter name, same general rules of variable naming also apply here. Okay, so that means that this has to start with some alphabet here, some alphabet. Then after that, you can have alphanumeric stuff. You can have underscore, but that's it. Now we will try to make some function. We will start with simplest case, and that will be function returns nothing and function also takes nothing. Okay, what we will do, we will just print something here. Oh, okay, let me just comment it out, the whole thing. Okay, now we have this function and we want to call it. So just like we were calling other functions here, we will simply call it saying foo. We will build it and then we will run it. And here we see that foo got called. So what happens here? We basically put this line outside this main. We wrapped it in this curly braces. We gave it a name. Okay, and then we are referring to this chunk of code with the name that we specified here. So when we compile, compiler will see that okay, there is some sort of function. Then it will find that this function is here, so it knows that wherever this thing is present, it is supposed to do something which results in this line getting executed. Okay, so this is the very simple case of it. Now, wait, case one takes nothing, returns nothing. Now we have case two takes nothing, returns something. For example, let us say I want to return an integer. Okay, and I make another function. So since I want to return something, I will have to specify the data type of the thing that I want to return. If I want to return an integer, it has to be an int. And then here I have to do something and then I have to return something. So for returning it, what I will do, return, say I got it. So I want to return 10 here. Now and num equal to bar, and we can print this thing here. And here we see that num is equal to 10. So basically we are returning this from here and we are basically storing this in this variable, and then we can use the variable in any way we are happy with. Okay, then we have a combination. We can also have takes something, returns nothing. So since it returns nothing, it will be void. Then we give it a name and it takes something. So this will be basically some type. So for example, I want to take a string and then I want to do something with the string. So we can print it. And then we can basically call this function and we have to specify some data. And here we see that parameter a string has been printed. We specified deadbeef here and it has appeared here, just like we expected it to be. Then we can have a case where takes something, returns something. Okay, and now we can have uh, suppose we want to return a vector of strings. And we can take some number here or maybe something else. Num. Okay, and then what we will do, std vector std string return value, and then we can basically we print it. We can run it again. And here in this we are saying that we got a vector and we are able to iterate over it and all the contents are here. Okay, so this is how generally functions are defined and used, and obviously a function can have multiple parameters, for example int num char ch std string something something, and we can similarly pass the parameters like this. Okay, now a function can take many parameters but can return only one thing at a time. Okay, so if you want to have a function which takes say 3 parameters, it is fine, you can have that. If you want to have a function which returns two values simultaneously, that is not going to happen. Okay, you want to return three values? Nope, not happening. You can return either nothing or only one value. And if you want to have a function where you can return integer at one place and string at another place, vector at some yet another place, no, that is also not going to happen. Okay, you can return only one type, and even for that type, you can return only one value at a time. You can have a function which returns different values at different invocations. That is fine as long as all values are of exactly same data type. Okay. Now, for parameters, there are two ways we can do things here. One is that we can copy the values. Okay, so suppose I specify something here. Okay, let me take another example. Uh, okay, suppose I am taking this particular example here. Okay, we have this data, and what I do after I print this, suppose I am overwriting it. Okay, and I build this again. Wait, which function is this? Magic. And if I run it, parameter is deadbeef. Okay, let me do a little bit change here. Std string, and then I will print it again. Original parameter is okay. Now you see parameter that appeared here. It is deadbeef. That is fine. Then this parameter is being overwritten here, but I am not seeing that change here in original parameter. It is left intact. This override did not really modify the original copy, and this is because uh, this is pass by copy. Okay, that means that parameters are duplicated and a copy is given to called function, which means that original variables will not be modified even if function modifies the given parameters, which is the case that we saw happening here. Okay, here you are modifying and the modification is not appearing here. Now, is there some problem with this approach? Anyone? We want to call a function, we want to pass some parameters, we are making a duplicate copy of all the parameters and we are passing that to the function. Is there something possibly problematic with this approach which can be an actual problem down the line for us or in some specific case? Yeah, modifying the copy. So, okay, so there may be case where we want to modify the original itself. Okay, yes, that is one use case which will not work at all with this pass by copy thing. Anything else? anything which does not involve the use case of modifying the original parameter. Anything? No, we are, see, we are making a copy, right? So once we make a copy, these two copies are pretty much independent, that is given. There is something else that can be problematic. Okay, here goes the answer. The parameter that we are passing has no guarantee that it will be small. Maybe we have a vector and that is a huge vector with possibly hundreds or thousands of individual objects that it is storing. And if we want to pass that entire vector, or maybe we are copying bunch of arrays from here to there, if the size is large enough, repeated copy can be a problem, right? Obviously, you will be wasting time on copying, specifically, more especially so if the function does not need to modify it for any purpose. Okay, for example, we can have function where we are not modifying the parameters, so we don't really need the copy, right? It can just read the original parameter directly without involving the copy. So, or maybe we wanted to modify, and in that we want to eliminate this copy stuff. Both cases are there. So, what we can do, we can use a neat little trick, and that is called pass by reference. So what happens that instead of passing the duplicate copy of the variable, what we say to the function that, okay, hey, you want a parameter? We have the parameter in memory at this location. So if you want to read the value, please go to that location and read it from there. We are not going to copy it for you. And by doing that, we are basically eliminating the copy. So how do we do that? Uh, Instead of this, we can specify a reference like this. So after this, we can have this ampersand, and this basically means that instead of a copy, this will take a reference to the past value. Okay, so if I build it again here, and I run it. Now I passed by reference, but my original parameter is overwritten. Maybe I wanted that to be overwritten. Maybe I was expecting the function to modify the variable that I am providing to it. For example, in case of this string stuff, maybe I want the string to be modified in place, right, in the same variable. If that is the case, it is fine. But I may not want this thing at every location or for every function, right? What if I am using some third party function which is written by someone else and I have no control over someone else? I want to avoid the copy, right? And the next person who has written the function, he also wants to avoid unnecessary copy. So he is expecting a reference. Okay, so I know that if I am passing some variable, it is going to use pass by reference and not by pass by value. But I do not trust that function to not modify my variable. Basically, even though I know that I am going to pass a reference to my variable, I want some way to prevent the function from being able to modify my original copy. Okay. So in that case, what I can do, I can give a constant reference. Okay, and if in function, if I want to take a constant reference, so what I can do, I can put a const keyword. Okay, and now it will not even compile because, well, we are trying to override the constant, but still, let us hit compile and see what is going on. See, this says that we can't really do this thing here. So I will modify this data. So if I see that this function is expecting a constant reference, that is where I know that it is not going to involve copying my variable, but it will also not be able to modify the original variable. So I get best of the both worlds. I removed the memory overhead because there is no copy. I also eliminated the risk of original variable getting modified because I don't really know, because I see that function is taking a constant reference instead of a non-constant reference. Okay, so we can compile it again and uh, run it, and this is working as expected. Now, someone can ask that, okay, here for this constant reference thing, we are relying on the person who made this function. I mean, the developer of this function has to put this const keyword here, right? Since that party is external, we don't really have any control over here. So if this function is expecting a reference, if it is not expecting a reference, it is expecting a copy, then it is expecting a copy. We can't really do anything there. But if it is expecting a normal reference and not a constant reference, can we make a constant reference somewhere here somehow and give it the constant reference instead of normal reference? Will that be okay? Anyone willing to take a guess? No answers? Okay, I will write the question. Here, question, if function expects a normal reference, can we forcibly pass it const reference? This is the question. Okay, and we can pass it const reference. So what exactly are we expecting to happen there? What happens if I provide a constant reference and the function tries to modify it? Here is the short answer. Bad things happen. Even if we can, in some very specific cases, any attempt to write at that reference will result in undefined behavior. Okay, so don't do this. Absolutely not. And when we say that this is undefined behavior, this basically means that C++ standard says absolutely nothing about it. It just says that this is undefined. And by saying undefined, it means that absolutely anything can happen and all bets are off. There will be compilers which will try to do not totally insane thing, but there will also be compilers, or maybe the same compiler which is doing the kind of expected thing it at one place will do some completely different thing at some other place because of this undefined behavior. And at that stage we do not get to point fingers at compiler. Compiler is not wrong. Okay, so whatever you do, be very, very careful about this undefined behavior thing. There will be many other cases where this undefined behavior will come up, and I will try to keep pointing that out, that this particular thing is undefined, this particular thing is unspecified, so on and so forth. But going forward, make a note that wherever you see that something is undefined in C++, make sure that you do not touch that even with 100-meter pole, because if you touch it, bad things can and will happen eventually. So if you see the cases where some people are suddenly crying or making lengthy blog posts saying that, oh my God, we just upgraded our compiler and now our code is crashing left, right, and center. We are losing the data. Data is getting corrupted. In 99% of the cases, they are either hitting undefined behavior or they are hitting some sort of race condition. There is no third category. Having that serious bug in compiler or standard library itself has very low chance. So be very careful about this. So when you see that function expects a normal reference, you pass it normal reference. You do not try to forcibly pass it constant reference or constant anything for that matter. You take anything constant and you do some trickery to force compiler to generate code for modifying it. That is completely undefined. All bets are off. Absolutely anything can happen. Compiler can generate code to basically destroy your data, set your laptop on fire, destroy entire internet, entire humanity. That is perfectly okay in eyes of standard. Okay, now we have done this pass by copy, pass by reference. Now, for a good practice, if you are writing some code, good practice, by default, take parameters by constant reference. Reason being, you are eliminating an unnecessary copy. Okay, and by taking a constant reference, you are also basically hinting the compiler and the next developer both that you will not be modifying the parameters that you are taking that way. Okay, and if by mistake you try to modify it, compiler will refuse to compile and it will basically point out to corresponding line in source code saying that, hey, you are doing something you should not really be doing. So you get to fix that mistake then and there. Now, there can be cases where you explicitly want to modify variable. If you want to modify original variable, take normal reference, pass by value only for trivial data types. That will be things like int, char, float, etc. Okay, so by default you should be sticking to constant reference in parameter. Okay, now there. Okay, any questions so far? Anyone got any questions? Okay, now we come to the next question. We have this function and we have this question. What if I want to pass a function as parameter to some other function? Can I do that? Okay, so in case we want to do this, we can wrap the function in std function and turn it into some sort of function object. And once we do that, we can pass it around like parameter, we can return it like a return value. We can store it somewhere like uh, some other object. Arrays, vectors, maps, etc. can store function objects. Okay, not only that, you can even do some sort of hash mapping across this, right? You can have some sort of key value pair where your key is some string or some number or something, some other type of object, and your value can be some sort of this wrapped function object. All these things are actually possible. So now the bigger question is, why exactly would someone want to pass a function itself as parameter? Are there any use cases where we actually want to do that? Having function is fine, calling function is fine, passing values to function is fine, returning something from the function is fine. Why exactly would we want to pass function as a parameter? Can anyone tell me any use case where function as parameter makes some sense? Dynamic invocation, yes, but what problem is that going to solve? Sure, we can invoke some function dynamically based on some sort of condition. Yes, that can be done, but again, why? What is the purpose? Again, see, lambdas are a way to do this thing. The question is, why do we even want to do this thing? We have dynamic invocation, yes, we have lambdas, we have std function, we have bunch of other esoteric things. But the question is, what problems are these going to solve? Yes, to implement callback mechanism. That is the biggest example. Probably you want to deal with some sort of events. Okay. For example, you might have your code structured in a way that, for example, let us take, we can take example of network communication. Okay. So there are basically two ways to deal with incoming data over the network. Option one is that you keep waiting for data to arrive. You repeatedly poke the operating system asking that, hey, do I have some more data? Do I have some more data now? Okay, how about now? Please tell me I have some more data. So you keep in a tight loop and you keep poking operating system, hey, get me data, get me data, get me data. And operating system will keep going, hey, we don't have any data, we don't have any data. Okay, now we have some data. Again, we don't have any data. Second option is you basically do the opposite thing. Instead of continuously poking the operating system or whatever framework you are using, you can say that, hey, I don't want to poke you repeatedly in a tight loop. I will give you this function. So whenever you get something on the network, just call this function. Okay. Same thing you can do when you are dealing with some other sort of events. For example, you are monitoring the system for some sort of event, maybe some file modification event, process creation event, that sort of stuff. So again, you can either waste a lot of CPU trying to cycle through and poke the system asking for more and more event, or you can just give it some functions, and whenever some suitable event happens, that function gets called. Okay. Similarly, you can do the same thing on this HTTP related stuff as well. You can either poke the network stack via operating system for more requests, or you can just provide it some sort of function that, okay, just tell us something like this happens, and basically call this function and it will be taken care of. So that is one really good use case where we want something like this to happen. There is one other use case, and the other use case is that we want to have some sort of generic way to do same operation on different data, but we do not want to do all the implementation on our own. Okay, so instead of saying that, okay, I want to multiply every element in the array by 2, so we write code for that. Then we want to add everything in, add 5 to everything for a vector, then we write code for that. So instead of doing that, we can have one generic function which can take some other function and some other basically your data store, an array, a vector, or something like that, and it will just run that function on every single element for you, right? So you only have to implement the only part where you are modifying the variables, and you can forget about rest of the thing that will be taken care of automatically. So largely there are these two cases. Use case one is callbacks, event handling, running same small code on different data container classes, etc., etc. Okay, so before we pass it as parameter, we will see how exactly we can implement it as this thing. So what I will do, we have this thing here. So what I will do, okay, yeah, here is the function call. So instead of doing this directly, what I will do, I will turn it into some sort of lambda. So I want to, wait, let me include that header as well. Include functional, and I can convert it into std function. Okay, does it return something? Magic? No. Void const std string foobar equal to magic. Okay. Fun magic. And instead of doing this here, I do this. So what I have done, I have wrapped this in this std function object, and I am calling that function via that function object here. And this works just like normal function call. Okay, so the syntax for this thing is really simple actually. It is std function, then we have this here, and we have return type, then we have parameter data types. Okay, and then here we have some variable name. Okay, now if you see here, I have not given the parameter name. Okay, we don't need to give that here because, well, this is not a complete function. I am merely telling it that, okay, the function I am going to wrap will take one constant string reference and it will return nothing, right? The name is important here because, well, here we are capturing the data, so we need that in some sort of variable, and that variable has to have some name, right? Here we are not creating any variable for this because, well, this is not really a complete function. So we can call it like this. And then what we can do now, we can pass this to some other function. Okay, so what I will do, I will declare another function. And what I will do here, const std. Okay, so what I will do, std vector, std string data, and then I will take a function which returns nothing and takes const std string reference. Okay, and now what I am going to do, I am going to take that const reference from this data, and oh wait, I have to specify function here, and then I am going to call this here. Okay, so what I am okay, so what I am doing here, I am taking a vector of strings, I am taking a handler function, and then I am calling the handler function on each entry in the vector. So if I want to do this here, I can remove this std vector std string data equal to okay, so we have this, and I want to call this function here. So this is foobar, first parameter is data, second one is this, and okay, where is that function, this magic. So here we can pass this directly as well. Okay, and we can run it, and here we see this getting printed that this is data. Okay, so basically what is happening, foobar is taking this vector, this function, and it is calling this function for every entry in this vector. Now okay, any questions so far? uh, Vivek, you can type in the chat. Okay, no questions then. Now we have done this. We can similarly also return a function from another function. Okay, so let us try to do that thing. We want to return, let us say it returns an int, and it takes two integer. And now what we will do, we will declare a function now the option one is that we can implement this function internal function int a int b, and let us say we are returning a plus b here. So we can either do something like this and then return this. Okay, let function, fine. Then here what we can do, we can std function int do something equal to return function. Okay, and then we can do something like this, do something 2 3. Okay, so what exactly will happen here, we are calling this will give us some function which is basically this function, and then we are calling this function via that returned function object by passing parameters to it. So since we are doing a plus b, we should see 5, and here we are seeing that 5. So this is working as expected, but there is little bit of problem. And here I will put this code on screen. Can someone tell me what exactly is problematic here? Or more like, is there something we could hypothetically do to make it more simple? When you spoke of that multiple parameter examples for passing function, were you speaking of the periodic functions? No, I was talking about functions which can take more than one parameters, but fixed number of parameters. Anyway, for this code, is there something which we can hypothetically simplify? No one? Okay, here it goes. I want to return a function here, and for that I have to define this whole goddamn function. And when defining this function, I also have to give it a name. Okay, and this is a name that is not really getting used anywhere else. So why should I have to think about this name? Especially because if I give it some name, I can't really use the same name for some other functions because the function names kind of have to be unique. At least the set of, at least this function signature as a whole, it has to be unique. So I can't really use it somewhere else for some other function which will actually be used by its name at many other places. One name is lost and I want to avoid it, right? So what I can do here, instead of doing it like this, I can kind of copy paste this somewhere here, and it will look something like this. Okay, and now I don't really need this separate function with its own name anymore. I can just remove this. And what I have here, let me kind of restructure it little bit. Okay, so this part is basically lifted straight out of the previous function. Okay, this set of parameters, this is again lifted out of the function, nothing unusual. Here we don't have to provide any name because we don't really care about its name. We are simply returning it, and whoever is going to get the returned function is going to store it in some variable with a name. So from that point going forward, it will be used by that variable name. So we don't really have to put any name here. It can be a function without name. Okay, so there is no name. And for this one, this square bracket thing, this is kind of a special snowflake where we can basically capture something which is outside this function and make it accessible inside the function. But that is something else that we will cover at some other stage when it will actually be useful. For as of now, you can treat it as a special snowflake here, and then you can just specify parameters and specify the function just like that, and we can compile it. And here, as usual, we are getting the same output 2 plus 3 because we specified a plus b here. Okay, now there is another question. What if I want to invoke a function partially? What does this mean? We have a function, let us say add a comma b, and I do something like a comma 5, and I name it as add 5a. Is this thing actually possible? Okay, what is the use? If it is possible, what exactly is its use? Anyone? Can you think of any use case where such partial invocation will be of any use? Fewer arguments, but why? Okay, here's the answer. There will be many cases where I am doing something and I want to have multiple implementations which differ slightly. Okay. For actual concrete use case, for example, you want to have some sort of input output routine and you want rest of the modules of your code to be able to read from or write to either network or file system or this console directly, right? But if you want all your modules to have all three functionalities, you will be doing the repeated task in pretty much every module. Okay, you will be checking for whether you are supposed to deal with a file or network or that interactive terminal, and for file you will be basically opening the file, setting it up for either read, write, something like that, or setting up the network stuff, either connecting or accepting some connection, reading, writing data from the socket. So basically you are doing the same thing again and again and again. So instead of that, what I can do, I can implement this IO part in one function that is super generic. Okay, and it can deal with basically all three. And then what I can do, I can based on some other parameters to other modules, I can provide a partially specialized copy of this particular function, right? So at that stage, the separate modules don't have to worry about network, file, terminal, or something else. All they have to worry about that, okay, I want to take input, I call this function, I want to give output, I call this function, and how that function is working is none of their concern. It may be talking to internet, it may be talking to some service on local machine, it may be talking to the file system, it may be talking to some attached console, some local console, remote console, whatever, right? The consoles don't have to think about it, and they don't have to even worry about what sort of what is the source of their input. They only have to think in terms of, I get this input, I give that output. Okay, so in those cases, these can be very handy, especially for abstracting away your use cases from rest of the code, right? So you can write rest of the code without having to worry about these nitty-gritty details everywhere. If this feature is not there, then you will have to think about different input sources and output destinations in your code at multiple places, and you will have to deal with many of them in slightly different way, right? By having this one nifty feature, we basically eliminate that entire thing and provide a really good abstraction then that can be abstracted behind this thing. And this thing works on top of this thing. Okay, so first we have this, and once we have this, then we start doing some funny things. I mean, we are already doing funny things here. We are passing it as parameter, returning it as return value. So why not do some modification on the function? What can go wrong? So what we do, we had std function, right? Then we have something called std bind, and what it does is magically binds some values to some parameter of the source function. Okay, and then we can pretend that this is yet another totally normal looking function with no magic involved. We can keep our eyes closed, don't have to think too hard about it, and we can just use it as any normal function. Okay, so wait, what? Now it is time to do something. So suppose I have a very basic function here. Let us take an example of this one. We are getting a function here anyway. So what we will do, we have this do something, right? And we need partial invocation where parameter 2 is always say 5. Okay, so what we will do, we will just declare another function, and it will be std function, and we are taking only one parameter, new function, and it will be std bind, and we are going to bind this do something. We want to pass 5 in second parameter. So first parameter has to be passed originally, and then I pass this. Okay, and then I do std cout new function and I give it 3. Time to compile it and time to run it. And here I call this new function with parameter 3, and it added 5 in that because we specified second parameter for this do something to be 5, and this do something is coming because of this where we have this a plus b, so that 5 plus 3 it becomes 8. Okay, so here what we have done, we are basically saying that this is the original function, this takes 2 parameters. Okay, so we have to specify basically 2 parameters here. When we want to specify some hard coded stuff or some variable, we can specify that. But when we want to say that okay, this has to be some sort of placeholder, and by placeholder I mean that whatever comes here has to be passed along here. Okay, so I here we have only one parameter, so I do this placeholder underscore 1. So this means that whatever I get out of this will have this first parameter, and whatever is put at that first parameter will magically appear here, and then this and this, they will be passed to this, which will eventually arrive here to do this a plus b thing, and we effectively end up with 8. So this is how we generally do this partial invocation part, and it is not necessarily true that you do this only once. You can do in chain as well. You can basically restructure the arguments. You can change their order of passing as well by doing this sort of stuff. You can specify only one parameter, two parameter, or maybe you can specify all of them and turn it into some sort of function which takes no parameters at all. All those things are completely possible, and there is no restriction that you can do this for functions which take some specific type of parameter. That is wrong. You can do it for pretty much any function. The function taking function as parameter, you can do it for that as well, and you can specify that function parameter for some other function via this binding thing. Okay, so there are basically no limitations about this. Okay, any questions? Okay, what is meant by partially specialized copy? So what do I mean here? That we have this original function here that takes 2 parameters. And here what I am doing, I am saying that this second parameter has to be 5. No questions asked. So I specified it partially. There are 2 parameters. I am specifying only one. So it is partially specified, and that is another copy. Any questions? Okay, I will take it as no questions. So we will wrap this session here, wrap up it here. I will copy paste this random stuff that I dumped in notes, and I will dump this copy of code both on Discord channels. Okay. I will also share some reading material, some stuff on these boost string algorithms, possibly some sample codes as well. Boost website has bunch of sample codes, so I will find something and I will share that. Similarly, I will share some reading material about this std function and this std bind as well. Okay, so I expect you to go through all of that and do little bit of practice. At least go through the working examples that will be present on those web pages, try to replicate them, and try to play with them so you get at least somewhat comfortable around these things, because these are the things which will be we will be seeing again and again and again in upcoming sessions in one format or another. Okay, so it is really important if you kind of practice it, and if you get questions, you can ask in Discord. So far, I think no one has asked any questions in Discord. You can ask the questions. You have some code that is not working. You want me to take a look at it? Just put it there, tag me. I will try to find some time, look at code, and try to figure out what is going wrong. Okay. Okay, so there is a comment from Aryan. Today's lecture has been quite confusing for me. Aryan, if I am to take a guess, this is probably because of this std function and std bind. Is that true? Oh, yes, yes. Yes, this will look kind of wacky to you because one, you are not expecting to see this thing happening in C++, and point two, this partial invocation is not really a thing that you get to see in many other languages. You get to define functions, but you have to specify all the parameters in most of the mainstream languages. So yes, this is a little bit confusing for everyone who gets to see this particular functionality for first time. Uh, but again, C++ is in no way unique to have this particular feature, right? This std bind thing is actually called currying, and this is coming from functional programming. So if you take a look at languages which are in group of that functional programming languages instead of procedural or object oriented or something like that, you will see these two concepts being really, really popular there. So there are concepts of like pure functions. There are concepts like meta functors. There are concepts like monads, monoids. There you will even see some concepts which are coming from a specific branch of mathematics called category theory. Okay, so all these are really popular in functional languages. It is just that we picked some really useful things out of those functional languages and we just slammed that in C++. And that happened because before this was a thing in C++, Boost implemented it. And when I say that Boost implemented it, what I mean is that they did not modify the compiler to accept that sort of trickery. Okay, they only wrote a library which magically made these things happen with any standard compliant run of the mill compiler. And that basically discloses one more fact that unlike many other mainstream languages that you get to deal with, C++ is a programmable programming language, which means that at many times you will be able to extend the features of language itself without having to modify the compiler. And that is exactly the case with this std function and std bind both. Boost managed to do this entirely by writing a library which could work with pretty much any run of the mill compiler. I am more acquainted with the C style than C++. Yes, actually, it is not about C. It is more like if you have not seen these functional concepts. So for first time, these will be kind of confusing. But with some practice, you will be able to understand it just fine. Especially if you keep along and start using them to solve some actual problems in your life. Anyone else got any questions, comments? Okay, there are no more questions and comments. Animesh, I think we can I have posted a question on Discord. Okay, you can tag me there. I will take a look.